All right, here we go. We'll start with our warm-up and move from there. This is February the 20th, 2014. Just a reminder, our test is going to be on Tuesday. Our assignment is due on Tuesday. We have one lesson tomorrow, and it's, again, sorry, one big lesson today, and then tomorrow we're going to do more word problem things, and then Monday will be the formal review, and Tuesday will be the test. This one says 2 cubed, 3 squared, x4y cubed times 2, 4, x3, y squared 5 all over 3 cubed x cubed y cubed cubed. All right. Sahil, I'm going to start with you because you're sitting at the front. But more importantly than that, Sahil, if you've seen this in a lesson, plus on yesterday's warm-up, plus on today's warm-up, what's that suggestion for you probably? What does that mean? Yeah, because this one's probably going to be on your test. Okay, so if you're still having questions with this, we're going to continue to go through this again every day because I know this is tricky for people. Sahil, you have the top left bracket. Can you do that for me, please? Go ahead. So I'm just going to put this here.
2, 9,
Yep, 2, 9, good.
2, 9, 3, 6, 12, 1, 3.
Now, Sahil, you're not off the hook yet. Can I bring the 2 and the 3 together to make it 6 to the 15 or something weird like that?
No, because the base has to be the same.
Awesome. Did everyone hear that? The base has to be the same. 2 and 3, they're both numbers, but because they're not actually the same number, you can't do anything to smush them together. They mean this 2 and the 3 here, right? Like, so you can't change that to a 6 or anything like that. You have to keep them separate. Okay? Cassie, you're up second. Cassie, can you do the top right bracket for me, please?
3 to the 20.
2 to the 20. Yeah. 2 to the 20. Keep going.
X 15.
Yes.
Y.
Good. Lindsay, you're up third. Can you do the denominator for me, please?
27.
Yes.
Is 3. 27 to the X. 27 to the Y.
No.
I thought.
I think what you did, like 3 cubed is 27, right? That's 3 cubed is. But we're going to just leave it in exponential form here. All we're just going to do is just going to multiply the exponents, right? So the base stays the same. We just did 3 to the 3. So 3 times 3 is 9. 3 times 3 is 9. And then 3 times 3 is also 9. Okay. We don't need to actually, tell you what that is. When you get it to the 20, that's a huge number, right? Like that's enormous. All right. Are we feeling somewhat okay with this? Yeah, question. Go ahead. No. No distraction?
No. How come on the bottom the 3 outside the bracket turns to a 9, but on the top the 3 stays at?
Which part for the exponent you mean?
Yeah,
Well, the base is still the bases are still 3s.
Outside the bracket there's an exponent.
Oh, there's 3 here, you mean?
Yeah, it changes.
Right, because it's going to get multiplied by all of these.
The one on the top didn't change.
It didn't. It should have.
Well,
It's because y equals 1.
Oh, okay.
Y has an invisible
Oh, thank you. Now I know what you're asking. Yeah. Remember, there's an invisible 1 there, right? So what we did here, we just did 3 times 1 is 3. If you take a look on here on the top right, 2 times 5 is 10. Right? So it's always, the exponents are always multiplied together. Yeah. Tracy, you're up. What do I do now, please?
Do minus. So 2, oh, no, don't do that. You do 2 plus 10, 9 plus 10, or 9 plus 20, sorry.
Okay, it's easy for you to say. I'm going to do this step first, okay? And then we can combine them all together.
Oh, sorry.
What I'm just doing here is called collect. I'm just writing the terms together that they're the same. Now this again, you guys that are whispering, please stand as all here. And then y to the 3, y to the 10, y to the 9. For me, it's easier to write it like that. Just helps to organize. If you want to skip that step, is that all right?
Yeah.
Yes. Yeah. Okay, so just combine the change, that's an optional step, but it goes from there. Can I get a brave soul named Shannon to simplify the numerator for me right now?
So 9 times 9.
And careful here. What we're just going to do here, right, for this, the base of, what's the rule that we're going to use when you're multiplying these? Yeah, go ahead. We're just going to add the exponent. So the 2 is going to stay the same, then we're just going to go 9 plus 20. Okay, so go ahead, tell me 2 to the 29. Keep going.
And then plus, no, then, so we do times 6?
No, and this just is going to stay the same then, right? Times 3 to the 6.
And then x 12, or, yeah.
So what's the x going to be then? That's okay, right? So just think, since we're multiplying these, they're the same, we just add the exponent. So this is just going to be 12 plus 15.
Oh, okay.
So this is just going to be x to 27. And then y to the
Still be 13.
13, right? Divided by 3, 9, x 9, y 9. Hey, Chris, finish this question off for me, please.
Well, you have to do, well, the 2 with 29 stays the same.
Yeah.
And then 3, negative 3, well,
Yeah.
the exponents. And
Yeah.
then x 8,
18.
18? Oh, yeah, 18.
Yeah.
And then y 4.
Good. I'm going to write it like this, too. Okay, sorry, Leah, your question there, and I snub you there. Go ahead.
Sorry to go back a lot, but
Yeah, it's okay.
I don't get how, like the first 2 I understand, is the
Yeah.
question, the second one, but then the third one, I don't
From
know.
here to here, you mean?
Yeah.
Okay, all I did for this is I just rearranged things. That's all I did, because these are all multiplied. So I started with 2 to the 9. I wanted to group all my 2's together, then all my 3's together, then all my x's together, then all my y's together. So I just went across it. Here's a 2, there's a 2, bring them together. Okay, then this is easier to do. Now, you can skip this step. I'm sure John is saying to himself, Mr. Sadler, I totally skipped that step, okay? You can go right from here to that in one line, okay, and that's fine by me, okay? The problem is if you skip too much, you make mistakes. That's why I show everything in a million different ways here. So I just rearranged, put all the 2's in my 3's.
You forgot to add the negative 3.
Oh.
I mean, you forgot to add the negative 3.
Oh, this one here?
Yeah.
No, I didn't. No, this is okay now, okay, because 3 to the negative, if it's a negative 3 in the numerator, it means a positive in the denominator. Because remember we said that x to the negative 1 is the same as 1 over x to the 1, right? So therefore 3 to the negative 3 is going to be 1 over 3 cubed.
Okay, so if
Right?
it's,
If it's a negative in the numerator, it means a positive in the denominator. First one. Okay, I'm sensing tension here today. Are we starting to feel somewhat okay about this? Somewhat okay? Yeah, go ahead.
Wait, so why is the 3 on the bottom?
Because it is a negative here, right? Because if you take a look, I have 6 3's in the numerator and 9 in the denominator. If you cancel out 6 of them, you're left with 3 left over in the denominator, right? Because there's more.
Why is it
Hear me?
denominator? Yeah.
Well, because there's more in the denominator. That's what a negative means. There's more in the denominator. So if you go up to here, right, there's 9 in the bottom, 6 in the top. You get rid of 6 each, there's still 3 in the bottom. You can either write it as negative 3 or 3 left over in the bottom.
But isn't there usually more on the denominator?
Not always. Depends on how I write the question, right?
But I mean, like, if it's small, yeah, like that.
No, not really. Like, look, like you guys are used to seeing fractions like 2/3, right? That's what you guys are used to seeing.
Yeah.
But like, there's nothing wrong with 18 over 5, right? Like, the amount of money in my account is 1,001 over 100. That's the money my account is. That means I have $100.01. That's what it means I have, right? $100.01 is what that would be. If that's a fraction, that's a lot more in the numerator than the denominator, right? You guys are just used to seeing stuff like this, right? But if, you know what I mean, that's, I would say it's more common. It's just a number, right? It doesn't really matter. Yeah.
would that not be an improper fraction?
This totally would be an improper
So
fraction.
you could turn it into,
You totally could. The amount of money in my account would be $100 and 1 over 100, which would look less impressive. Like 10,001, that's a lot, right? But it's not. And you guys all know I'm cool. Okay. All right, let's keep going here. I'm gonna go through the rest of the homework here. I'm gonna get paused in the studio because this is starting to take too long. And then we'll keep going.